ladies and gentlemen, hello and welcome back once again to the Briefing Room. My name is Eric Cavanaugh. I will be your moderator for today's event, in which we're going to talk about one of the more exciting topics out there in the world of managing data and information, real-time data distribution when tomorrow is too late. That's the exact title of our event today. And let's start moving through the slides. So here's a slide about yours truly and enough about me. The mission, as many of you know by now, of the Briefing Room is to reveal the essential characteristics of enterprise software. And so what we do is we pair innovative vendors with independent analysts to conduct a live analyst briefing. So that's what you're going to see today, folks. The analyst and vendor do not coordinate before the show. And the reason we do that is because we want the questions from the analyst to be the kinds of natural questions, organic questions, if you will, that an analyst would ask when getting an update on a particular technology or product. So I will say that attendees always give some of the best questions, so please don't be shy. You can send them in at any time using the Q&A component of your webcast console, or you can chat them to me as well. Or if you're on the Twitter world, you can tweet with the hashtag of BriefR, and we'll get them that way as well. So September is Integration Month. We cover a different topic every month, primarily because we want all of you out there to have good apples-to-apples comparisons when trying to understand which kinds of technologies or which specific tools can help you in a particular situation. So we realize and appreciate that when you purchase enterprise software, it's a very serious decision, and you're going to want to make sure you have as detailed and granular of information as you can possibly get. So that's why we do different topics each month, and of course we only broadcast at 4 o'clock Eastern on Tuesdays. Same bat time, same bat channel. So data integration is the topic this month, and really it's one of these topics that just keeps on slowly evolving and changing. Obviously there are many tools in the toolbox for the data integrator. ETL has been the sort of heavy lifting tool for many years now, extract, transform, load. But data replication is a very interesting technology as well for feeding data to systems maybe that need them faster than you would get them if they had to go through, for example, a data warehouse or some other route. So data replication is very good for a variety of things. Of course, disaster recovery is good for data replication, real-time analysis of a situation of some kind of data feed, whether you're in perhaps manufacturing or if you're in retail or even in pharmaceuticals, and you really don't want to wait to get a certain set of data to make a decision. Well, that's the domain of real-time data distribution and data replication. So change data capture, of course, is another popular technique. A lot of people are using streaming technology, streaming data these days to get some of the stuff that they need in the time that they need it. So there are a lot of different use cases out there, a lot of different things happening, but of course the bottom line is that people need to get the information that they require to make their decisions. So data replication is one of the critical ways that companies can really circumvent a lot of the more cumbersome processes or workflows in order to get the data they need in a very timely fashion. So the analyst today is our very own Dr. Robin Bloor, of course, Chief Analyst here at the Bloor Group. He's been talking a lot about data flows these days and the importance of really knowing what your data flow architecture looks like, because as time goes by and more people demand information either for analytics or for their operations or, for example, for your website, for inventory, something like that. As people have these greater demands, well, what does that do to the data managers? It puts more pressure on them. And the bottom line is that if you can ascertain exactly what your data flow architecture looks like, that can be very useful for streamlining business processes, for streamlining the actual movement of data, and that can save you time, it can save you money, it can save you headaches, and obviously it can also improve data quality, and we all know that bad data is not something that you want in your organization. So Sybase, of course, was bought by SAP not terribly long ago. They provide enterprise and mobile infrastructure development and integration solutions. I've actually been tracking Sybase for many years now and have been very pleased, I suppose is the word, with the manner in which SAP has embraced the full Sybase platform. So sometimes when a big vendor comes in and gobbles up a smaller vendor, even if that vendor was pretty big, well, not everything gets taken along, and it's my impression, at least, that that integration has been fairly well done. So we'll be hearing from Bill Zhang. He's a veteran at Sybase. He's been focused on this area for many years now, so he's a real expert in terms of replication. And Tom Traubitz, Director of Analytics Product Marketing with SAP, will also join us during the Q&A. So with that, Bill, I'm going to hand the keys to the WebEx over to you. I'll push your first slide, and now you should have the floor. So take it away.
Thank you, Eric. Good afternoon, everyone. My name is Bill Zhang, and let's talk about Sybase Replication Server. And so Sybase Replication Server has been in the market for more than 20 years now. So this is a very mature enterprise technology. And how our customers are using Replication Server for, just want to give you a snapshot. Disaster recovery is very popular for the database, one of the original use case used for by the Replication Server, and also the real-time reporting, right, providing the just-in-time information from a production OLTP transaction systems to the reporting system. So this is another popular use case in terms of how Rep Server is being used. The other one that we're seeing getting more and more spotlight is actually the data integration. And so customers are using Replication Server to just-in-time, let's say, data consolidation or data distribution type of environment, and that doesn't go through a very complicated workflow process, and it just goes straight from database to another instance of a database. So this is how we're seeing in terms of a Rep Server used in the industry today. So I grouped them in terms, there's a lot of use cases we just mentioned, but kind of grouped them into three use case scenario. The first one is what we call data distribution and the data migration. And one of the area that we're seeing become very popular is how the replication is being used is basically migration. So think about if you have a legacy environment, and give an example, possibly you're on the, let's say, HP Unix environment, and you want to migrate to Linux. So, and what customer now they want to see is they want to see zero downtime during the migration. So replication can be used in that environment, basically providing the zero downtime migration for a lot of mission critical databases. And also data distribution. Think about you just published a new pricing information, and you want to populate those pricing information to downstream your retail store. And then what's the best way to do this is actually through replication, right, in real time. So you can push out those pricing information. And conversely, you can actually collecting your sales information in real time, and from all those retail channels you have to the headquarters. So this is what we usually call, it's called a corporate roll-up type of use case. So this all belong to data distribution and data migration. And the characteristics is really, I'm only replicating the subset of data, right? I'm not replicating the entire database. Now, another popular use case I just mentioned is real-time decision support. So either let me create an identical replica of the production database, and then I can run the report off the replica, or let me just replicate the subset of the tables and where replication, the reports will be run. And so this is a popular use case, and then where we're seeing about 25% of the customers are using Replication Server for real-time decision support, and the growth in that area is tremendous. We're seeing almost every year double-digit growth in that space. And then the last one has been used for a long time is really the HADR, database HADR. Now we're seeing about 25 to 30% of customers are using Replication Server for is HADR, and the growth in that area has been pretty strong as well, because we're seeing a lot of mission critical applications now do require HADR support, and the Replication Server is the best technique in terms of providing HADR for database, right? So there's another way that you can do HADR through the disk replication, but a Replication Server, software-based Replication Server is the best way to protect your database from corruption and all that. So HADR is another popular use case for Replication Server. So this is a very typical topology in terms of HADR. So by using Replication Server, not only we can prevent, let's say, natural disaster, right? So let's say if there's some earthquake somewhere and you want to switch over from your primary to secondary, so Replication Server can help you to do so. But more often than not, what we're seeing is there's a lot of planned downtime. Rather than you run into earthquake and power outage, a lot of customers, they're seeing the planned downtime. Let's say if we want to do OS upgrading, or if we want to do, let's say, database migration, all those planned downtime, a lot of customers also want high availability of the system. So by using Replication Server, you'll always have a live database running at your DR site. So this is something that what customers are looking for. They want a live standby database able to switch over instantaneously without downtime. So this is really giving a lot of business advantage by doing so. So this is a typical topology for HADR. And the next use case is, the next picture is really the very typical topology in terms of real-time decision support. As I mentioned before, you can either copy a subset of your production database to the target, in this case is the DSS operating system, or what you can do is creating the entire database, right? So you can make a snapshot of your production database and then run report out of that. So this is just two techniques. But one thing that I want to mention is you don't have to create another infrastructure for real-time decision support. You can do is actually just take advantage of the previous HADR setup you already have, and then piggyback on the same infrastructure and then just replicate the subset of database or subset of tables from the production database. So by doing so, you basically it can lower your total cost of ownership by leveraging the same infrastructure for HA, by leveraging the same infrastructure for real-time decision support. Now, the third one is the data distribution. So the key thing here is really the continuous replication of the change data. Erica mentioned it before, the change data capture. So Replication Server is one of the original techniques to facilitate the concept of a real-time CDC. So the continuous replication is the key here. So whenever there's a insert, update, delete happening on the production database, or the source database, what I can do is basically replicating that insert, update, delete to the target database side. And whether it's, let's say, the source database in this case is ASE, and the target database could be Microsoft SQL Server and Oracle and IBM. There are different applications running on top of it, but how I'm integrating in this case is really from a database level. I'm replicating from a database to another database rather than integrating the all those environments through the application layer. So this is the key distinction between the database replication versus other integration techniques. And in this case, one thing that I want to mention is the Replication Server being very flexible, powerful topology. So what we can do is you can do either one-to-many. This is how this picture depicted. Also, you can do many-to-one or many-to-many type of topology with the Replication Server. And also, we're seeing a lot of customers are using Replication Server to do bi-directional replication as well. So one of the examples that I was given that, hey, you can not only push down your pricing information from the headquarters, in the same replication route, you can actually roll up your sales information in real time to the company headquarters as well. So this is bidirectional replication. A lot of time that I'm replicating to the same source so that there's some built-in context detection and the resolution technique built into the replication server as well. So it's a very powerful tool that to dealing with data distribution. So let me give you a replication server in a nutshell. And one of the secret sauce within Replication Server is we're not actually touching the database itself. How Replication Server will run is we're actually going into the transaction log, be that is Sybase ASE, Oracle, or IBM DB2. So we're only touching the transaction log, meaning that there is no impact to the production database at all. So really giving the nature of a non-intrusiveness. And also what we're doing is we're replicating the transactions, right? So we're replicating the transactions from primary to secondary. And so by doing so actually prevents any of the data corruption. So we're not replicating the actual data. We are replicating the transactions. And the second thing is the near real time. So as soon as you have a committed transaction, insert, update, delete, in your primary database, I can immediately getting those insert, update, delete transactions from the transaction log and sending to the downstream databases. And also through the built-in technique, we pretty much guarantee the database delivery or guarantee the transaction delivery. So we guarantee that consistency between primary and the secondary. And it is using store and forward technique. So just in case, let's say your target database is down, I can store all those intermediary transactions in my stable queue within Replication Server. When the target database is up, I can apply all those transactions to the target database side. And also, not only we replicate insert, update, delete, this is the DML language, we'll also replicate the DDL as well. So let's say if you do alter table, alter index, those type of DDL, we replicate that as well. And on top of it, we are providing industry-leading store procedure replication as well, basically to improve the replication volume and also reduce the latency between source and target. So the database, one of the key things that I want to mention again is really the database integrity is guaranteed, and because we're replicating the transactions, not actual data itself. So it's unlike some of the hardware disk-based replication, there's some corruption. We do not replicate that because we only replicate the transaction. So in terms of flexibility, as I mentioned before, we support, this is a multiple database vendor support. So not only we support Sybase ASE, but also we support Oracle, Microsoft SQL Server, as well as IBM DB2 on the mainframe, as well as on the Windows, Unix, and Linux. So this is on the source side, but on the target side, we also support messaging bus. Sybase IQ is the data warehouse tool that we have, and also other databases that I just mentioned. So now it doesn't have to be in the same subnet. You can basically, if your primary database could be in New York and your secondary database could be in Denver, or as far as if you just go to Europe. So this is very flexible topology and by Replication Server. One of the very exciting things that I want to mention here is we just introduced last year. We're seeing a lot of our customers actually taking on this new technology is the concept of a multi-path replication. So in a previous architecture where you can see is I have a one source, one target, and we have a one replication path between source and target, right? So there's a bottleneck, right? So if you want to increase the replication volume, reduce the latency between source and target, the best way to do is actually to parallelize, and then basically you can subdivide the replication stream and then parallelize all those replication streams. So we introduced the concept of a multi-path replication. So if you look at the bottom half of this picture, we can have a multiple replication agents that are reading the transaction log from the same transaction, from the same database, and then sending all those transactions in parallel to the downstream replications. And this multi-path replication concept is end-to-end from source all the way to the targets. And what we're seeing is depends on how many, let's say, replication server you have. It's almost near linear type of replication performance improvement. So basically, the more replication path you have in between source and target, the more replication volume you're going to replicate and the less latency you're going to occur between source and target. So it's a very exciting new technology that we introduced to the market, many exciting use cases that the customer that we're seeing, they're taking advantage of this new technology. So let me turn back the floor to you.
Okay, actually I'll bring in Robin Bloor. Let me go ahead and hand over the keys of the WebEx to you, Robin, and you should be able to just click anywhere on the slide and use the down arrow to move your slides.
Okay, well that seems to be working. I find replication, I thought that was a very interesting presentation by Sybase, and it has to be said that I remember having the first presentation, and I think it was 20 years ago, about Sybase's replication capability, and it's much more sophisticated than it was then. But even then, it was a fairly innovative thing to be doing. People didn't think in terms of replication for a lot of these tasks that it's now being used for. So anyway, I want to talk about the orchestration of replication, but I want to talk about it in respect of data flows. The first thing, to say really is we need to duplicate data. We will not get away without duplicating data. We duplicate it all over the places. I think there's an average of 3.5 copies of every piece of data in the typical corporation. It may even be worse than that, So we duplicate data, that's what we do. So really the question is not whether we're going to do it. We do it, and we have to do it, but how best to do it. And that's kind of what I want to talk through. The first thing in terms of data duplication, when I say there are multiple copies of everything, a lot of things that you might not initially think of as data duplication are in fact data duplication. So database logging, yes, you're logging data that's also going to the database, and we duplicate that for the sake of recovery. There's the database backups, full database snapshots. Well, we're duplicating that for the sake of having a recovery start point. With data warehouse, we're taking feeds of information from multiple, possibly even hundreds of applications. And we're duplicating for the sake of data consolidation, so we've got it all in one place, and we can put queries against the full inventory of data, or as much of the inventory of data that we can fit in the data warehouse. We do data staging, which I think of just generally. We often end up with files that are intermediate between one place and another. Often, for instance, going to a data warehouse will perhaps have a reserved time when it can take data. So we end up with this intermediate data that might not have a particularly long life, but again, it's duplicated data, and we're duplicating it for the sake of data flow. We do database subsetting all over the place. I mean, we even invented the word spread marks, I think, in the past, 6 or 7 years, to indicate the extent to which data marts are being pulled out of various data warehouses or even other data stores. And the reason that we're doing that is quite simply for the sake of performance. We would love for all of those people that have access to data marks to be flying off the original data or flying off the data warehouse, but quite simply the data store that we use in those contacts won't stand it, so we create data marts. And that's duplication, and it's done for the sake of performance. And then we have, and this has been fairly recent, but I think it's at least 10 years old, the idea of the operational data store, which was, well, the data flow that takes the information into the data warehouse and then eventually squirts it out into various data marts for people to analyze, is taking a long time, let's say days. There are certain queries we want to run that we really need to be running against data that is not that old, maybe only an hour old, maybe even only minutes old. In order to support that, we have an operational data store, and of course the operational data store is a duplication of data. So look at all of this, and you see, geez, we're duplicating data everywhere. And obviously there are complications involved in that, because like having all the data consistent and knowing which particular time your data mart actually applies to in respect of what the time is now. And a lot of issues. So this is the if-only slide. There's an application that I would love for someone to develop. It's called the Something Truly Magical Happens application. And if we look at the top here and we imagine all applications pretty much have data. We would like them to be able to go to only the data they want. And we have at the bottom here all the data. I mean, this is a bit of a fix really, because not all data is in databases. Some is in data files, but I kind of think of any organized data as being a database of a kind, really. It's a database that's either entirely disorganized or somewhat organized. And we would like there to be a Something Truly Magical Happens application that sits in the middle and grabs the requests from everything at the front end, goes exactly to the places in the back end where the data is, gets them, and throws it back at the applications. We'd love that to be the case, because we spend a genuine fortune on buying, building, implementing software to do exactly that, to do nothing more than connect an application to the data that we want it to be connected with, the data that's coherent, the data that's consistent, the data that's timely, and so on and so forth. And we can't do it, and we are miles away from doing it. And I'm betting that my career as an IT analyst will have ended long before anybody actually does fix this. So the question is really what we're doing in terms of data flows, and we discover that pretty much all of the data thrown from one place to another, to another, to another, is being managed in terms of the performance that is eventually required by the end application that uses it. The performance isn't just about the application going to the nearest database and getting the data, it's having the data arrive at that database in order that the application can do the data. So this isn't just about performance, but performance is a major driver for the way that we build the data layer at the moment. Because we can't have a single coherent distributed data store, that was my kind of position on the previous slide. Looked like all of those databases were all independent, were mutually exclusive, and contained all the data that was required of them. That just isn't the case. And because we can't have in any way a single coherent distributed data store, we have no option but to think in terms of data flows. And this means database plus middleware. And I hate to use the term middleware for replication. I think Sybase would probably describe it more as database technology. But middleware is pretty much the lousiest term that the whole of the IT world has ever invented, and it has many meanings. It can be applied to ETL, it can be applied to ESBs, it can be applied to data governance products, it can be applied to data virtualization products, and so on and so forth. But the data flow is about database plus something in the middle that's making the data flow around. And the truth is that the data flow service and the database service levels, the service levels for these two parts are very, very strongly interrelated. If the data flow doesn't deliver the data to the database at the right point in time, then the user will not get the data they want to see. They will get an untimely view of the data. So it has to arrive on time. It probably has to leave as fast as it can. In other words, when the data is created, for the sake of data flow, it would really be a good idea that as soon as a write goes to the database, a write goes somewhere else into the data flow that's taking it. And that's one of the really appealing things about replication technology. But I like to think of these two things together because in terms of the data layer, data flow and database, one hand washes the other. And if you think in terms of the applications, then both hands wash the face, and that's the way it is. So database replication is a critical capability, in my view, primarily because of its performance characteristics. It is, it gets the data early and it drives it there fast to the place where it's required. And that's the attraction of it. It isn't necessarily the best solution to everything, in my opinion, but it's certainly a solution worth looking at. So what I thought I'd do here was just take the first slide that Sybase put up and just mention these capabilities, the 6 capabilities around the circle that Sybase showed. Disaster recovery, what is it? Well, it's an extreme service level, and often it's an expensive service level. High availability, that's a service level thing. You want high availability so applications don't go down. When applications go down, users are without the service the application provides, and therefore they possibly are sitting idle. Real-time business reporting, well, that's a data flow and a service level thing. It's data flow because the stuff's got to arise on time. And it's a service level thing because the user at the end of it is probably wanting to act upon that information immediately. And actually you have situations of real-time business reporting where you're just reporting it to other software which wants to go off and do something instantly anyway. So that's a data flow and service level thing. Load balancing, that's a service level thing. Data integration, that's a data flow and service level thing. This is pretty much all, the way you look at this. It's only the last point, data assurance, where we realize actually that if you're going to have data replication, it'd better take its security with it. Databases are really, really good in their ability to actually pin down and apply security, even at an item level. And if you're going to have replication, then you want the replication capability to be able to drag the security with it. That's just what I would call a kind of obvious factor, but one that people don't often think about. So, having said that, having run through that set of ideas, that's the way I come at this. I've looked through Sybase slides and just listened to the presentation. The one thing that I hadn't fully realized from looking at the slides, which I got, last week, was the parallelization capability. And I'm almost inclined to go at that immediately, but in actual fact, I think I'll do a few of these questions that I prepared earlier first. So, tell me if you can. Replication sounds like a really neat idea, and from a certain perspective, it looks as though it's actually, I know you can get complicated, but it looks as though it's actually fairly simple to organize. So, well, the first question that I would ask if I was in a situation where I'd never even thought of replication as a solution to some of the things I was doing, first thing is, well, what was it going to cost? And I'm not really talking about what's the license fee. What's it going to cost in terms of changing the way that I do things? What does it reduce the storage costs, or does it increase them? Does it, I'm presuming that maybe various intermediate files disappear, so maybe we're saving data. But does it save data? Maybe there's another overhead. Does it put a higher load upon the network, and so on and so forth? So, as a general question, in basic terms, what are the likely costs, and also what are the likely implications in terms of other possible follow-on costs? Yeah?
Yeah. Thanks, Robin. So actually, usually how we, first of all, to answer your question is, I want to say that, like you said, license cost possibly is minimum to a lot of enterprise customers. And the product has been in the market for more than 20 years. So in terms of human capital managing this, ease of use is definitely there as well. So how we actually, what we're seeing from customer side is they often to calculate that by, let's say, do not have the software, what kind of cost that it will happen. So in the scenario of HADR, high availability, and the disaster recovery, what if, let's say, without having the replication software in place, and I don't have a, let's say, a data duplication technique in place, what if I lost those data? So data loss has become very, very expensive, a lot more expensive than the software cost as well as human capital cost to manage those software. So I think a couple of years ago, I see one research report they're saying is, give an example, in financial services industry, if I'm out of service for 1 hour, the cost could be, let's say, $10 million per hour if I don't have the data. So think about those type of costs and compare to the software cost and the human cost as well as additional hardware cost. This is and then the comparisons is pretty obvious from that perspective.
Yeah, I kind of agree with that in the sense that outages are extremely expensive, and to the extent that this can limit the amount of outages, then it's a very strong argument. And the actual cost of outages, or even outright data loss, but you've got to use this technology properly to prevent those things. But the costs of that are so high that it's almost it's difficult to mathematically kind of size them up against the other costs associated. But yes, I can see that that on its own, a really good disaster recovery capability or a really good backup and recovery capability provided by replication may well pay for itself simply because it does it better, does it more timely. So let's go on to the next question.
Hi, Robin. Before you go on to the next question,
okay.
this is Tom. I'd just like to add a couple points. Replication intrinsically is a synchronization engine. So its main costs would be in the use of the network. However, when you compare it to other networking schemes, such as moving the entirety of data between two systems, replication is actually very inexpensive because it is actually only replicating the commands of change. So it's replicating essentially the instructions to change, not replicating all the data that may be between the two systems. So as a synchronization engine goes, it is actually a very efficient way for your usage of network, which is why it was originally invented. It was invented for wide area networks where you did not want to be overly taxing those because of both reliability as well as cost concerns.
Right. Well, I guess that even feeds into the next question, because the next question is where is there a performance advantage when replication replaces other data flow strategies? And you've just said, of course, there is in the kind of circumstance you described, there is actually networking load advantage, and it allows you to do things over a WAN which you might not want to do over a WAN, or which you might not actually be able to do because of the bandwidth of the WAN. So yes, but in other areas, where's there a performance advantage?
I think that Bill, maybe you'd like to, give a little bit of color around multipath, because one of the unique things about our replication technology is its ability to take advantage of multiple network paths versus a single.
Absolutely. So because I'm very close to financial services industry, and I would like to give you an example, right? So a lot of Wall Street customers in New York, they are using Replication Server. One of the use cases actually what they're talking about is the real-time risk management. And so basically the faster you can replicate your production database in those cases are actually the trading informations, right? So the captures that you, the tradings that you just conducted for could be equities, could be fixed incomes. You capture those trades and immediately you replicate those trading information to the risk management. So, and then the risk management system is able to calculate based on the trades that you just conducted, give you a risk profile. And so the faster you can replicate and let the risk engine to calculate risk profile, the less risk that you may have. And then basically based on the risk profile, then you can come up some hedging strategy for your profile. So this is something that we're seeing more and more, a lot of customers start using this. So basically the faster you can replicate data, to the risk engine, and the faster risk engine can come up with some hedging strategy, the less loss you may have. So this is some of the performance advantage that we're seeing to translate from technology level to the business level.
Okay, and I mean, I'd like to go into that parallelization thing in depth. I mean, nobody is ever going to argue the fact that if you start running things in parallel, then you're going to get a faster movement from A to B, or you're going to, in one way or another, be able to move a load of stuff faster. But what I wasn't particularly sure about when you were explaining it is exactly kind of how it worked at the physical level. I mean, are we talking about parallelizing over the same network lines, so you're dividing the workload up at the beginning and at the end, at the two ends, and you're kind of multiplexing between the middle, or are you talking about raising the bandwidth so that if you just raise the bandwidth and you're parallelizing at each end of the line, then you can just kind of have almost a control of the speed over at which data passes. So kind of at that level, how does it kind of work?
Yeah, sure. So let's say if your bandwidth is limited, right? Let's say your bandwidth is fixed, and So usually the bottleneck in your replication system is how fast you can read your production source database and how fast you can actually apply those transactions to the target database, right? So the multipath replication is the way that to actually speed up the database transaction log reading and speed up the database transaction applying to the target database side. So then if, let's say, if there's any way that you can increase your bandwidth, then definitely you can multiply those replication paths between source and target. The more parallel path you have, the more performance you're going to have. But let's say if your bandwidth is fixed, I'd still be able to increase performance because I'm eliminating the bottleneck on the source and the target side.
Right, yeah, I think I understand that. And if the audience didn't, then you're bound to get questions. But I think I know what you're doing. And that makes a lot of sense to me. You know, you're effectively parallel at both ends, and you can actually control the bandwidth in the middle and boost it, and that will make everything go faster. So the next question, I kind of sat and thought about the idea of, let's just imagine that I was in charge of the whole of the IT capability of an organization, and I looked at what we'd done, and we hadn't really done much replication. Hadn't even got your product. We'd done bits of replication here and there, maybe some disk mirroring and so on and so forth, at the hardware level, for example. And I'm thinking, well, let's imagine that I come to the conclusion that I actually want to use this strategically. Then there are two things I'm going to do. One of the things I'm going to do is I'm going to apply it to new applications when we build new stuff. But the other thing is I'm going to look at the stuff that already exists, the existing data flows, and I'm going to say, let's do some software modernization. So I know the tendency of the industry when people buy product is to do new stuff with it. But I'd be interested to know if you have a fair amount of activity that one would describe as software modernization, or let's say applying replication to existing applications where something else was already being used. And, you know, can you speak to any use cases? Because I think that would be interesting.
Yeah, sure. So this is actually, you brought up a very interesting thing here. What we're seeing is since Sybase is being bought by SAP, as you know, the SAP is providing a lot of very exciting cloud applications. So running the SAP ERP applications on the cloud. And of course, you have a lot of applications, or let's say legacy applications on-premise. So Replication Server as technique that can be used to synchronize or to migrate your existing data sets on the on-premise side to the cloud side. So this is basically to facilitate this either database migration or software modernization type of data flow from on-premise to cloud, and basically providing very seamless, zero downtime type of a migration. So this is one of the phenomena that we're seeing, and then actually this is how customer actually demanded from SAP.
Okay. Well, my next question was really how would you divide it up in terms of usage between that? I mean, that's a very specific example, and it's a very obvious one, and it's one where I can see the obvious sense of it. But, you know, just in the general sense, would you say that most people are just simply throwing this at new situations, or if not, then roughly what would you say that the division is between modernization and actually just using it in new situations?
So the software modernization, this is an up-and-coming trend, and then has been actually, the demand has started, I would say, about ever since SAP acquired Sybase. So right now, what I'm seeing is about between 5 to 10% of replication customers are in that catalog. And the thing is that the growth in that area we're seeing is tremendous, because just giving the same example here is think about cloud by a lot of CIO is being really the cost reduction, right? So I'm I'm running all my infrastructure, basically let a cloud provider to run my infrastructure, and all I'm paying just the subscription fees. So this is one way that how CIO is viewing the lower the total cost of ownership, and they want to quickly migrate all their existing on-premise applications to the cloud. So this is very critical, and we're seeing the growth is going to be very tremendous in that area.
Right. No, it kind of doesn't surprise me, actually. The next one is like, this is looking at it from a strategic perspective, and I just thought, well, you must be very familiar with the customers that use it most. So I'd be interested just in you kind of talking through one, and you don't need to name the customer, just name the circumstance, one of your most extensive use. So, you know, you've got on various slides, you've got different descriptions of how you may use this. So who's using it strategically, and what does that look like is a question, really.
Yeah, sure. Absolutely. I can provide one example. One of the, I would say, one of the largest U.S. bank, of course, they do have a worldwide presence, and that they use the replication server not only for ASC database, but for Oracle, Microsoft, as well as the IBM DB2. How they're using the replication server for is basically to collect or to capture, rather, all the trade information. So let's say if you have your equities application running on Sybase ASE database, your fixed income applications running on Oracle database, and your foreign exchange applications running on Microsoft SQL Server. So all those trading applications constantly running, and you want to have a replication server. In this case, is actually capture the trades as soon as it's being executed, and then what they do is using replication server to fetch all those information or trades to another database. In this case, is Sybase ASE database. What they will do is that within the ASE, they will run about maybe 50,000 to 50,000 covariance matrix to calculate value called the value at risk, and then in real time. So they will distribute that VAR value to downstream applications. Let me tell you the scale of this operation. On the source side, they have about 14 source applications, all the trading applications within the firm, and the downstream applications that subscribe the VAR value basically describe the risk profile that within the firm, and about 1,400 applications that subscribe to this VAR value. And this system is running 24/7 and a very, very scalable and reliable system that running within the bank, and has been helping them in terms of risk management for years and years. I would say that for the past 15 years.
Okay, that's impressive. Okay, I've got one more question, then I'll hand back to Eric, because we normally go to audience questions about 10 minutes before the end. And so the question of the ones that I've got left really is, okay, you've described various areas of usage. Where do you think it's inappropriate? Is there anything where you would simply say, this isn't where you use replication server? Go to data virtualization, or go to ETL, or go to something else. What would you say were the areas where you really don't think it's has a role?
Yeah. So one of the area, because the replication server is basically grab the transaction from source to target, right? And then if your target database requires some extensive, let's say, transformation. So in that case, then possibly you would team up with replication server and let the replication server as a real-time change data capture mechanism, and then feeding that transactions to ETL, right? Not instead of directly going into a database and apply those transactions, what you will do is usually connecting a replication server system with ETL, so let the ETL does a lot of transformation for you rather than let the because replication server, it doesn't do much of a transformation. It does some, but it doesn't do as extensive as ETL does. So I would say that in those scenarios, you want to use Replication Server and ETL together.
Okay. Well, I think, I mean, I've come to the end of my time, so I'm going to throw Sybase to the lions in our audience.
Okay, good. We got a couple good questions here from the audience, and folks, you still have time, so don't be shy. And Bill, I'll throw one to you that came in early. It's an interesting and candid observation here. One of the attendees writes, I'm not getting the value proposition. The databases cited all have built-in replication functionality. Can you talk about how what you're offering here goes above and beyond some of the built-in technology that's offered by some of these database tools that you talked about?
Yeah, sure. So a lot of the database tools in the past, basically they have replication services as a part of database. So what happens here is when you started the replication, and guess what? On the production database, it will basically have a severe impact on your production database performance. So Replication Server, in this case, actually sits outside of the database and has a minimal or to no impact to the production database at all. So if we look at our product architecture, if we go to earlier, if I can switch over. So if you look at this product architecture here is all the replication agent, I'm actually running outside of the database. So meaning that there's no impact to the production database at all. And actually, we started about this about 20 years ago, as I mentioned, and our competitors such as Oracle, such as IBM, they all catching up. They go out and actually acquired some standalone replication tooling vendor that to do exactly what we did 20 years ago. But they just finished the acquisition. Let's say Oracle finished their acquisition 2 years ago. IBM finished their acquisition about 3 years ago. So they are just start catching up the concept that we've been employing for the past 25 years.
That's very interesting. I'm glad you clarified that. And so just to get some more detail here, is it the case that in each one of these different technologies, obviously you have to fine-tune what you're offering, and when Oracle, for example, comes out with a new version, are there minor changes that you make in Replication Server to optimize that connection, or how does that work?
So every time when Oracle comes out their new releases, and of course our Replication Server will go certified with their newest version. And so we are working with those database vendors such as IBM, such as Microsoft SQL Server, and as well as Oracle very closely. So every time their new version come out, we will certify them.
Okay, good. And we didn't talk too much. I think I heard Robin talking about it just briefly, this whole NoSQL sort of big data trend that seems to have dominated the industry. Are you seeing any use cases for dealing with that kind of what some people call multi-structured, or some people call it unstructured data, not the traditional data in a relational database, for example, but more along the lines of either let's say it's social media data or email data or anything like that. Are you seeing use cases with that kind of data with Replication Server?
So the database today is mainly deal with structured data and unlike NoSQL and all that, so it's I guess non-relational. So Replication Server dealing with a relational database. But having said that, we are actually adopting replication as a concept in the future, so doing some future-proof type of technique here. So one of the area that we are looking into is basically how Rep Server is able to work with Hadoop. So this is one of the area that we are looking into.
Okay, interesting. Okay, good. Here's another question from the audience. One of the attendees asked, it's a pretty good question, any order of magnitude for costs in terms of redundant capacity, replication resource, is there some tipping point? And I guess it's always going to be a case-by-case basis depending upon what your needs are. But I think what he's asking is, is there a point at which replicating too much data really becomes not cost-effective? And how would you figure out for your company where to draw that line?
It depends how critical is your application. So some of the ERP, especially the SAP Business Suite ERP applications, a lot of customers demand zero data loss or zero transaction loss. So Replication Server is actually implementing this zero data loss or zero transaction loss. So basically, any transactions happen on the source side will be replicated or duplicated on the target side. And some of the database or applications that actually doesn't require zero transaction or zero data loss, then you don't need to replicate the whole thing. So it really depends on the nature of the application.
I see. Okay, good. And now I remember Tom chimed in and was talking about the network and how the network, of course, in certain cases winds up being your bottleneck. I put this, actually I need to make myself the presenter here again so I can show this slide on multipath replication. I think this is very interesting stuff, and I'm curious to know what kind of data does Replication Server pull from your network and from your other available paths, basically, and how often does that refresh? And the reason I'm asking is, let's say a company, maybe financial services like we were talking about earlier, where you have these critical data needs. Let's say that one of those paths, one of those routes gets an upgrade. Some new technology is brought in where the network is stronger and faster. How quickly and how dynamically does Replication Server ascertain changes in the friction along these paths? In other words, how easily can it detect if there's a whole lot of activity on the network versus a little, and then dynamically reroute stuff?
Yeah, so the Replication Server can run as fast as your network, and in that case, let's say if your network gets really, really busy on one route, and the Replication Server do have some built-in intelligence to basically slow down the traffic on that route, and then let other replication agent to pick up the workload, and then go maybe take another route that was a lot more bandwidth than the current one. So the intelligence is built into the replication agent as well as Replication Server to basically to work with the network per se based on the network availability and the bandwidth availability.
I see. Okay. And there's a more detailed sort of sub-question now from an attendee. Can multi-paths have dynamic prioritization per path? And then can that actually occur as a job is taking place, or would it only change when a new job comes in as opposed to during an existing job recognizing that one path has slowed down and going to another path?
So what Replication Server, what multipath replication would do is that you can actually assign, let's say I have a two path. One path is dealing with a very mission critical OLTP type of transaction. The other path is just dealing with, let's say, very large volume batch job. And so you can assign, let's say, the mission critical OLTP transactions has a higher weight in terms of priority compared to the batch job. So, but you do have to assign that let's say the path 1 to the OLTP transaction and the path 2 to the batch job. So if you assign that priority that way, then the replication will work with as designed.
Okay, good. And one last question I'll throw out to you. I put up this replication landscape slide again because I think it does a really good job of showing that sort of strategic view of source to target. Are you seeing companies using, there's some database technologies that have come out and have really been flourishing in the last couple of years, and again, some of these are these NoSQL type databases, just very creative ways of storing information. Of course, many of them are optimized for the cloud. Are you starting to see customers look at the cloud and using some of these more creative database technologies to store data in the cloud, or is that still somewhat new?
I think that definitely there's an uptick there, and we do see customer is taking on NoSQL or using Hadoop as the way that to do a lot of massive calculation. So as I mentioned earlier, Replication Server is actually exploring the Hadoop type of technology to see how Replication Server to integrate with Hadoop. And one of the things that we're seeing is if you do have the structural or relational database, how can you use a replication server to convert your relational transactions into, let's say, Hadoop on the target side, which is maybe hosted on the cloud. So absolutely, we do see the uptick there, and we are looking into this area to see how we can best provide services to our customer.
Okay, great. Well, good answers to those questions. Thank you to our audience members out there who sent in their usual zingers. You can see the upcoming topics we have. Of course, the rest of this month is on integration. October is going to be database. November is the cloud. December is innovators. And then January we'll be going back to architecture. And I'll take a quick moment to plug our upcoming research, which is going to focus on the event-driven architecture. So keep your eyes peeled for that, folks. We'll be getting around to that in the fairly near future. Thank you so much for your time and attention. Big thank you to our friends at SAP Sybase and, of course, our very own Robin Bloor for his time today. This does conclude our event. We archive all of these webcasts at InsideAnalysis.com. So just look under Webcasts and then the Briefing Room and recent episodes, and that's where you'll find all these things. So thank you so much, folks. Take care. We'll catch up with you next time. Bye-bye.